my first point is like we are talking about like what is PLSQL. So to understand what is PL in the PLSQL, so it's a procedural programming extension to SQL. PL stands for procedural language. PL in the PLSQL stands for procedural language. It is like a third generation language that provides programming constructs which are similar to any other third generation languages. Like we can declare variables, we can get some data from the database and put the data into the variables and use the variable throughout the program. We can declare the variables, we can loop a particular set of operations n number of times as satisfying based on some number of conditions. We can do error handling through PLSQL. So basically PL stands for procedural language in PLSQL. As we all know that the SQL and PLSQL stands for structured query language. Basically SQL is used to insert, select, update or delete data. These are the main operations that are performed by the SQL. Basically we can call it as a SQL, like we can call it as SQL is window to the database. So finally we can say, when we compare the SQL with the programming language, adding programming language features to SQL, we call it as PLSQL. There is a basic definition of the PLSQL. So we'll see now why we need PLSQL. So through SQL we are able to achieve the results what we require from the database. But still, why we need to go to PLSQL? We need to go to PLSQL to keep our code secure. We need to handle exceptions and we need to give appropriate error message or display message when we don't get any necessary data from the database. For example, this is the basic table that which we get when we install DB, select star from EMP. This is provided by the Oracle. Okay, so suppose I want to check whether I have department number 10 and if any of the employee salary is greater than 5,000 and if such employees count exists more than 10, then increase salary of employees with 5%. This is a straightforward requirement we can achieve through the normal SQL only. But all we are trying to say why we need PLSQL is we can declare the number of variables wherever we require. We need not execute the update statement. Through PLSQL, you need to execute the update. Through SQL, you need to execute the update statement. But through PLSQL, we can just check, we can query it, we can directly check for the updations. So if you don't have any of such employees, like in department number 10, whose salary is greater than 5,000, where employees count exists more than 10. If any of these condition is not satisfied, ideally you need to report an appropriate message saying no such employees exist. If such employees exist and if some operation is performed, we need to provide appropriate user messages, whereas all that can be achieved in the PLSQL by using the exceptions. So going back to history of PLSQL, it was developed by Oracle in the late 1980s. It was introduced with limited capabilities in 1990. From Oracle 9a release 2, we also have the object-oriented programming capabilities where we can have constructs, we can declare objects, we can create objects in the PLSQL. To find what version I am working on in the PLSQL, this is the query to see. I have a database, I need to see what version I am working on it. So when you do select star from v $version, this is a basic query which tells me that the database which I am using is a 11G database. The PLSQL version of this is 11.2 and it is a 32-bit Windows client. These are all the information I will be getting when I say select star from v $version. Why I need a version? Why I need to know version of the database? Because there are several features implemented in 9i, in 10g, in 11g. If I want to use certain specific feature, I need to know what version of the database I'm working with. So these are the differences between SQL versus PLSQL. So if you see, SQL is a data-oriented language, whereas PLSQL is a procedural language. SQL executes only one statement at a time, whereas PLSQL executes block of statements at a time. Meaning, when I say block of statements, we'll be having 3-4 statements. We'll be sending everything one time at a server, and we'll getting the output. I'll tell you about the point 2 in the later. SQL cannot execute statements conditionally, whereas PLSQL can execute statements conditionally. This means that suppose execute a particular update statement or delete statement only if a particular query output count is greater than 10. Otherwise, don't execute that statement at all. Through SQL, we can't achieve it, whereas through PLSQL, we can achieve it easily. Through SQL, reusability of data is not possible, whereas in PLSQL, we'll query once, store the data in the variables declared, you use that variable throughout the program. So we need not execute the same query to get the same data again and again in PLSQL. Whereas in SQL, if you want to use the same data again, if you want to use it in some other query, you need to execute it every time we require. In SQL, exception handling is not possible, whereas in PLSQL, we can handle the exceptions. There are many predefined exceptions provided by the Oracle. We can also define a user-defined exception, saying that if this is the case, if someone is updating a salary of an employee more than 1 crore, you report an error. So this is a user-defined message. This is a application-related message. So we can define such user-defined exceptions in PLSQL, and if that is the case happening, we can report appropriate error message to UI. SQL is a common language used by many databases like Oracle, DB2, SQL Server, whereas PLSQL is commonly used to write data-centric programs to manipulate data in Oracle DB. So all we are trying to say is PLSQL is common to Oracle database. And using SQL, we used to code queries, GDL, and DML, whereas PLSQL is used to code program blocks, stored objects. SQL supports ANSI standards, or PLSQL does not support ANSI standards. I hope I'll get what do you mean by ANSI standards. So this is the basic architecture of the PLSQL block. So in PLSQL, in SQL, everything as we call as a query. In PLSQL, we'll call everything as a PLSQL block. I'll show you what PLSQL block consists of. Every PLSQL block consists of a declare section, one begin and end section, and exception section. So this is a basic PLSQL block. So declare section is always optional. All variables what we are going to use in our program, we need to declare them between the declare and begin section. If we don't declare any variable which we are using between begin and end block, this is called as executable block. If you use a variable without declaring it, we'll get an appropriate error message that variable is not able to form. The only mandatory block in this is begin with at least one executable statement and an end block. You can simply write begin, null, and end. This will get executed. At least one executable statement should be there between one begin and end if you are trying to use begin and end. Exception block will definitely says if we don't have this one, we are going to, if some error occurred between begin and end block, please report this as per the exception statement. I'll show you with a simple example in going forward. So what I'm trying to say is all such, sorry, one last thing. So between this begin and end, you can write n number of SQL statements. You can write n number of update statements. All that update statements, all that SQL statements will be sent to engine at a time. So this is a basic PLSQL engine. So PLSQL consists of PLSQL statements and SQL statements. So when we submit a PLSQL block to engine, it will be coming. There is a procedural statement executor will be having a SQL statement executor. All procedural statements will be passed to procedural statement executor for parsing. All SQL statements will be passed to SQL statement executor for parsing. Once the parsing phase is completed, the respective logic is respected and will be executed. That is the basic architecture of the PLSQL. Any doubts in the architecture? Sorry Jagdish, I missed your ping. I'll explain you the reusability of data once again. Okay, so when I say reusability of when I say reusability of data, every time we need some data from the table, we need to execute the same query every time. We can only get the data from the database through SQL only when we execute it. When I say reusability of data, I'm getting the best thing is I'll show you through ename. Okay, so if you see here, what I'm trying to do is in this basic structure, this is the basic syntax of using SQL in the PLSQL block. So all I'm trying to do is get employee number and employee name of employee number of 7369. I'm trying to get that values in these two variables, v underscore employee number, v underscore ename, and now I have those values in this entire program. I can use these variables when I want to check some data conditions, when I want to do some operations. I need not execute my query again and again. Now I can write some update statement, update emp, set sal equal to sal into 1000, where now if you see, salary of 7369 is 800. Now I'm saying, now I'm executing this basic block. 800 into 1000 will be the salary of this. One second. Okay, it's a database error. I'm just doing value of salary into 10 because more than that precision is not allowed. Okay, so previously salary of employee was 800. Now when I done with 10, 8000. So Of course, this is not a perfect example of data reusability. I can directly use 7369 here, but all I'm trying to say is you can fetch the data once, and you can use in the you can store it in the variables, and you can use it in the throughout the program. You need not execute with any query again. Am I clear, Jagdish, in that? Yeah, Jagdish, you're unmuted now.
Yeah, Sunil, here you have taken the employee number 7369 and put the employee number and employee name into the variable. So
yes,
and you have updated some condition. Yeah, and just given the variable name. So can I store the resultant of a SQL query into a variable?
Resultant of a SQL query mean I didn't get you.
Means like I have written a SQL query, and you get a result, right? Like based on some condition, and
for example, this
series of employees, maybe employees whose salary
department number 10,
right?
Yeah, this one.
Okay. Now we have series of employees, right?
We have 3 employees.
3 employees. So this can be put into a variable, the whole data.
Yeah, see, coming to that point, we have something called records.
Oh.
Okay, so in that records, I can completely store this complete data set. In record, I can store one complete data set irrespective of number of columns. I can completely store a record of a table in this record. One complete row I can store in the record. And coming to that point, if I want to store all the result sets, there is a possibility.
Okay.
So that is the advanced feature. That is the next feature of the. What I have shown you here is a basic example. If you want to store entire things, you can achieve it by combining nested tables to store all vertical columns. You can have you can store 7782, 739, 7934. When it's a nested table, you can call it as an array.
Okay.
And through record, you can store one complete row. So when you combine these two in Oracle, you can store the complete result set.
Okay.
Clear?
Yeah. Understood.
Okay, sure. So if you see in this example, this is a select statement. This is also a SQL statement. I mean, this is a SQL statement. This is a SQL statement. What are the variables we have declared here are the PLSQL blocks, this one and end. So all SQL statements will be passed to SQL statement executor. All PLSQL statements will be passed to procedural statement executor, and these will be passed, and the whatever the logic we have defined here will be respected and will be executed accordingly. So this slide shows basically what is a PLSQL. So it's a separator which splits the SQL and PLSQL statements. Every PLSQL block comprises of SQL and PL commands, and these both are submitted as one request. PLSQL engine split the block and sends appropriate commands to the corresponding units. Any questions there? Okay. I'm proceeding with next. Now we'll see like what are the advantages of using PLSQL. These are the major advantages of using PLSQL over SQL. So we can have block structures, we can have procedural language capability, we can have better performance. SQL, as SQL is tightly integrated with PLSQL, which again is the advantages of using PLSQL. We'll have error handling. We have something called bulk collection. All the objects are compiled objects. We have so many Oracle supplied packages which we can directly use it. We'll see a bit detail about what all these mean. When I say block structures, PLSQL consists of blocks of code which can be nested within each other, and each block forms a unit of tasks or logical module. So what I mean to say is, you can write n number of statements in when you execute this select statement in a SQL command. This one, I can execute only one command. Now if I want to update, I need to again run this update statement. So initially this SQL statement will be sent to server. Server parses it. Server does all the compilation validations, and then this statement will be executed and you'll get the output as result. When I execute the update statement again this will be sent to server, will parse it there, the necessary operation is performed, and the corresponding output will be displayed. But all what we are trying to say is, you can write such n number of statements in begin and end block of a basic PLSQL block. This, instead of here 2 IO operations will be performed, but in this case only one IO operation. We are saying all the related operations we are performing in one block, those will be sent to server, will be performing all the executing all the tasks, and then all the output will be displayed at a single go. So that gives us to define basic block structure. So that's what I mean. PLSQL consists of blocks of code which can be nested within each other. Each block forms a unit of tasks or logical module. So as we define, now we have procedural language capability. Here I can update this statement if salary is greater than 500, then only execute this statement. This means that PLSQL is having a procedural language capability. Now I'm trying to roll back. Now if you see the salary of an employee of 7369, it is back to 800. Earlier it got updated to 8000. Now if you see, salary of 800 is greater than 500. So to see that not execute this update statement, I am keeping the condition is making false. So now this update statement will not get executed. One second. Okay, sorry. Now if you verify, still the value is greater than 800. So what we are trying to say is, we can use such programming constructs in PLSQL, and we can execute a particular update statement only if such condition is satisfied. The same can be the difference between this and the normal update statement. When you write here also in SQL also we can achieve saying salary less than 500, then only execute it. But the difference between this and that is, this statement will be parsed, this statement will be executed, this statement will be executed, parsed, and then only it will come to know that there is nothing to update. But instead of that, this statement will be executed only if particular condition is satisfied. Otherwise, we are skipping the entire logic. This update statement will not even touch the database or search for the some data in the database. So that's what we say. PLSQL consists of procedural language constructs such as conditional statements, if-else statements like for loops. We have so many of such, and we can achieve through PLSQL like any other third generation language. And as I said, we can send more than one statement in PLSQL block. It gives always a better performance as we are processing more than one record at a time, and it reduces the network traffic. In our earlier example only, when we issue two SQL statements separately, two IO operations are performed. But then when we submit them as one block, all will be submitted as one PLSQL block, and only one IO operation is performed. So in a real-time scenario, we can imagine the count of the IO operations that are happening. As I said, SQL is tightly integrated with PLSQL. If we all the knowledge of SQL is going to help write better programs in PLSQL. We can write any number of SQL statements in a single block, and PLSQL understands all the syntaxes, data types of SQL. So no need of knowing SQL will be additional advantage of learning PLSQL. And in PLSQL, we have beautiful error handling messages. You can define a user-defined error message, and you can pass it to UI. We can display it accordingly. So PLSQL program will be executed abnormally. So it will exit with complete proper error message status. Even, for example, if there is no such employee here saying, I'm saying 143, there is no such employee of 143 in the database. If you see, 0 records fetched. So now when I try to execute this, now I haven't defined any exception block here, I'll get an error. I'm re-executing that. So if you see, the error is saying no data found. This is an abnormal execution. So if you use this block from UI, and if you don't define any exception block to handle such exceptions, your application will be terminated. Terminated in the sense user will be getting some nasty messages. So rather than that, there is a predefined exception. Exceptions are defined saying exception block. When this is a predefined exception, there is a predefined exception. So you can define when no, basically here the scenario is with 143, you don't have any record in the table. So when you don't find any data, what you want to do, you can define here. Probably I want to insert into some table that employee number and employee name. What has been, probably I want to insert that employee number which I received as input and not exist in the table, and later business want to review that information. I can define that operation here, and also it will be terminated abnormally because you have defined what action needs to perform. So that's what we are trying to say. Once an exception is caught, when you say no data found, for example, if you see here, when I say null, now you will not get this error message. If you see, you got anonymous block completed. Earlier we got it as something different. I can show you one more thing. Create table NSK ABC, employee number. Now I'm saying if you get no data found, I want that record to be inserted in this table. Now I don't have any data in this table. Now I'm saying insert into NSK ABC, employee number, values v_emp number. Now it got success because we have the error is 143. With 143 there is no data. So I handle that exception. When no data found, I am saying insert into this table. As there is no such employee number, I got it as null. So here we can say 143. So 143 is stored. So later you can submit this data to business users saying that these are all the exceptions that we got. So once an exception is caught, specific actions can be taken depending upon the type of the exception, or it can be displayed to the user with a message also. So we have millions of, in general, in the real-time scenario, we'll be having millions of rows in the database, and we need to perform some update operations, some delete operations to more than 1 lakh rows, 2 lakh rows at a time. So normal update statement saying update employee or update this salary may take some 10-15 minutes. So in general scenario, that time can be increased, and that time is unavoidable. We can't wait that much time. So there is a provision provided by the PLSQL. We can do bulk updates, saying we have some mechanism called for all constructs. We have so many methods. So we can fetch data 1 lakh rows at a time, and we can perform all the update operations for more than 1 row at a time. So when we go to the details of the bulk collection, we'll be using in this session how to improve performance of the update statements through PLSQL block by using bulk collection also. So basically you can find the difference between normal update statement and bulk collection update statement or any DMLs only when you have a large number of rows. So throughout in this session, in one of the class, we'll be inserting huge number of rows, like more than 1 lakh, and we'll be seeing definitely we'll be seeing the difference between the normal update statement. We'll execute a normal update statement, we'll execute a bulk collect update statement, and we'll see the time difference that we are going to get in that. And PLSQL, every time SQL or PLSQL or any other language, every time you submit some code, a set of piece of code to server, it will be compiled. In SQL, every time you submit a select statement or update or insert, whatever it is, that every time it will be getting compiled, every time it will be getting parsed, every time it will be doing everything. But in PLSQL, we have something called stored objects, like procedures, functions. We can define the complete logic in a procedure and function, and we can store that logic in that at server side. What all we are executing the statements are at client side. We can store some specific set of statements at server side that will be compiled only when you are modifying. So every time we call that or invoke the procedure or function, that will not be compiled. So by that way, we'll be having ready to use compiled objects. We have several Oracle supplied packages, like if you go to Java, if you go to C, we have printf, scanf to perform appropriate operations. Like in Java, we have sys.println. Like that, in Oracle, we have several supplied packages which we need to know how to use it, and we can directly. Throughout the session, we'll be using some of such packages like DBMS and output will display data to context. We'll see what is scheduler, what is this random package, how these packages works. Throughout the session, we'll be using most of the supplied packages and trying to achieve it. We have several new features in 10G. So we have improved built-in packages. We have quoting alternatives. That mean if you want to display quotes in the output statements, how we are going to handle that. We can have a beautiful feature of regular expressions in PLSQL. You can use regular expressions. Say you want to select all the employees who are starting with whose name has in middle SUN. If their name contains SUN, you can use through regular expressions. You can give case sensitive, insensitive, all that information. And in 11G, we even got a continuous statement in PLSQL in the programming language feature. We have something called PLSQL result cache. We are going to see all this. We have something called dynamic SQL enhancements. So all these beautiful features we are going to see in the session. We are going to run that through examples. So any Q&A?